Hey, hello guys, I'm making this video about through hole or surface mount devices, integrated circuit, how to create them on Spring Layout 6. Actually, Spring Layout 6 has a tool that you can actually use to create those difficult to do integrated circuit. This is just an example. As you can see, we have this package, a CO-8 package mechanical drawing of the integrated circuit. So I'm going to show you how to create one. I already did it before as I started the video, so it doesn't take too long. So I'm going to show you how quick is this to do. So one example, we have the information here. As you can see, the distance is, it says minimum 5.80, typical 6 millimeters or 6.20. You can go with 6 is just fine. You can go with 6. And then the other information that is really important is the pitch distance of between the leads of the integrated circuit. So you can see the letter E. I'm going to zoom here so you guys can see better. You can see that we have the letter E and we see the pitch distance. So but I noticed something here. There is like a little squares. You can see there is a little square. Those are the surface a contact that is going to be on top of the PCB. So right now there is another legend. You can see on this drawing. Let me see if I can. You can see we have the letter L. It will tell you how much space you will have in contact with the surface of the PCB. So right now we have the L, we have the E, and we have the E, capital letter E. So we're going to create one just from that information. So let's go first. This is the drawing. I already did it just to cut the time, but it is really simple to do. So I'm going to move this to the side. So we're going to create it one more time. So let's see. Let's go with extras. Right here on top you will see extras, and then you will see footprint wizard. That's the one that I always use. So I already typed the numbers here, but you can actually do it. Let me place it the way it was. It was like this. Okay, this is in the typical through hole option, so you can change it by press here. As you can see, there is like a little SMD pad, surface mount device pad. So the only thing you gotta do is click there, and you will see they are going to turn into SMD pads, so soldable areas for the integrated circuit. So right now I'm gonna use dual row DIP right here, DIP. There you go. So that's ready to go. So from the information, the only thing you gotta do is look for E. Okay, let's see E. Okay, we got E, capital letter E. It says typical 6 millimeters. Let's go with 6 millimeters. Let's see, Y, that will be the letter Y right here, and it says 6.20. I think I typed 6.20. Let's go with 6. Let's go with 6. I think 6 should be just fine. It's no problem. Let's go with 6. All right, so we got 6. I'm sorry about that. We had the letter Y, so that's the pitch distance between these two paths. This is a line of paths. So let's go to the information of letter E, minor E. I'll say minor E. All right, so that one will be, it says 1.27. It says 1.27 because it has to be a fixed distance at 1.27. So let's check now. D, as you can see on the D, let's go with D. I already typed it, is 1.27 millimeters, and then it's ready to generate that particular SMD device. This is ready. This one is ready to go. Basically it's the same as this one here. I changed some numbers here, but it's basically the same. As you can tell, I place it here, and it does not gonna fail. It's not gonna fail because it has the same distance. All right, so I'm gonna tell you something else. Okay, so you gotta give it a little bit more. You gotta make the path, SMD pad, a little bit wider, just a little bit. So one example, I made one already, but the distance, I mean the leads, I made it sort of like the similar as the original one. One example, the leads of this SMD integrated circuit is V. You can see the distance, the thickness of this little wire is really thin wire. So let's check that. So it's a letter V. It says 0.28 or 0.48. So what I did, I just made one that has the same information. You can see 0.48. The length of the lead is okay. You don't need to change. 0.8 is fine. I just need to show you that if I place this here, it will illustrate you how it's gonna look like on the SMD surface device. As you can see, after you drag the tip of the soldering iron, is going to seal this particular pad. I'm sorry about that, the wire, and we can make sure that I say that's the word. To ensure that we have the correct distance, we use the ruler here, the measurement tool, and we're gonna measure the distance between these SMD surface mount devices. I mean the pads. So let me measurement. We got 1.27. That's correct. So we're gonna type it here. The pitch distance is 1.27 millimeters. So that's good to go. So that's the pitch distance. Yeah, that's too big. What happened here? All right, so we got 1.27, and we're gonna measure the other one from here to here. We're gonna use the ruler, and we're gonna measure that to make sure we got 6.20. That's good. That's good enough. 6.20. So, like I say, after I place the SO-A package, you will see that it's going to fit correctly into the solderable area. So this is a photo view as how it's going to look like. And you can see after you drag this hot iron, soldering iron, you're going to feel all these thin wires from the SMD surface device thing. So it's not that really difficult to do. So here the tool of Footprint Wizard is really useful because you can create a really complicated integrated circuit. Also, it will apply for through-hole devices too. Through-hole device. Let's get one. A through-hole device. Something, you know. Just I needed just an example. Let's get a clock timing. All right, clock timing. Let's go with the through hole. Let me see if I can find through hole. A through hole device. There you go, through hole device. Through hole device means that the component, it will go through a hole. Sorry about my pronunciation, but that's the way I say it. It sounds funny the way I talk. All right, so we have these components. Let's get one that is simple to do. Okay, CMOS. Okay, we got one CMOS. All right, we got this one, and then you will go to the data sheet. What happened here? Something happened. Cheeky breaky. Oh shit! What happened here? Cheeky breaky. All right, let's see. So we have. Oh damn, this is old. What happened here? This is old information, something like that. Let's get to the data sheet of the layout. The information of the oh, there you go. We got it right here, guys. So this is the information. We're gonna look. Always try to denote the first. I forgot to mention that, guys. The first pin is this one here. So you will always place sort of like a little circle. You will place a little circle to indicate that this is pin number 1. So it will go like this. Pin 1. Dang, that's a big number. Pin 1, and then you will continue counting 1, 2, 3, 4, 5, 6, 7. Wait, hold on. 1, 2, 3, 4, 5, 6, 7, 8. Sorry about that. I say, what the hell is wrong with me? All right, sorry about that, guys. I was thinking about something else. So we had pin A. So let me move this over here. Oh, it's okay. So okay, so we got the pin number 1. 1 2 3 4 5 6 7 8. So you got it. So this with the circle means that that's a pin number 1. Some people they place this thing, this drawing. I'm going to show you. Maybe they're gonna place this drawing here to denote that this is the front of the integrated circuit. Some people do this depending on the situation also. So let me split the group just to make sure that I have it correctly. Let me see. Okay, split the group one more time. I need to see the center. Oh, that it's not centered out. It's okay. It's fine. It's fine. It's okay. It's just an example, guys. Some people will place that symbol right there. All right. Okay, so let's continue to create this one here. Okay, we have the pin number 1. Oh, and then you will count 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. So this is the pin number 16 and pin number 1. So you can place a number 1 here, or maybe you want number 1 here and number 16 here, so you can count. So right, okay, let me see the distance. All right, so we have here 10.92. So we need to know, okay, the wire, you see how thin it is? The wire, it says maximum 0.53 millimeters. So you can go with 0.60. 0.60 should be just fine. So all right, so now we're gonna create this one here. So we had 16 pads. We have 16 pads, and the distance that I need here on the legend, it says 10.92 maximum. I think I should go with 10. Yeah, 10 should be just fine. So let's create it. All right, let's see. 10 by 2.54. 10 by 2.54. Okay, let's do that. All right, I need a single row. Sorry about that. Dual row. Dual row. Okay, so I need 16. So I need 8 here. Okay, and the distance, let's go with number 10. And the distance between the pad is 2.54 millimeters. So that's ready to go. And yes, the drilling should be 0.60 and a little thicker. Let's go with that. That's fine. That's fine right there. That's the one. I gotta turn this into copper C2. Okay, this is one thing that I gotta tell you guys. As you can see, it turns green. That means that it's not a true pad hole. It's not a true pad. You can press F12 and you will turn it into a true hole device. As you can see here on the information, you will see that it's a true pad. Sorry about that, it should be true pad. I forgot to mention that. It is a true pad, so you will have solder on both sides. If you don't want to have it solder on both sides, on top, on the bottom, you can press F12 and it's going to turn it into a simple bottom solderable area of the PCB. So it's gonna look like this, just the holes. You can see it's just the holes by itself. But if you press F12 on the keyboard, it's going to turn it into a solder, both top and bottom. You will have solder, so it is more difficult to remove it after you solder, unless you use you know, those I think they call it those sockets that you can remove the integrated circuit really easy and then swap it off with another one. So that's a good idea right there. Also, you can change the shape of the pads. You can either have a square shape right here, square. You can be octagonal, or you can use this type of pad. Let me show you. You can either like that. There's many options of the shape, or you can do it like that also to solder the integrated circuit. So that one is ready to go. So the only thing we need now is the sort of like a drawing of the, let's see, okay, we have the A and we have It says 6.60. Let's go with 6.5. It says A measurements. This is 16 lead. With 19. It says 19.69. 19.69. Let's go with 20. I think we should go with 20. I mean, it does not need to be a perfect number. You can add it. You can square that out. Maybe 20 is fine. I mean, it does not need to be perfect. Okay, let's go with 16 leads. Let's go with 20. 20 by 5.5. 20 by 5.5. All right, that's fine. So let's draw that. Let's go with 20. Okay, a little bit more. Getting closer. 20. That's fine. 20. And then it says, let me change the shape of this. Oh, there you go. That's better. Depending on the situation, how you want it. So I will leave it like this. The pad I think is too thin. Let me make it a little larger. Okay, let's go with 2. That's fine. It's fine right there. So we had a hole is 0.60. It's fine right there. So on the information it says 6.60. This one here, 6.60. I will go with 6.50. 6.50. All right. Oh, let's see. 6. Maria, let's see. There you go. That's fine right there. Okay, there you go. So we have this drawing. It might not be precisely how you call it, aligned with the path, but you will do the best you can. I think it looks really nice right there. It looks really nice. Yeah, it does. All right, so now we need to identify the hold on, sorry about that, guys. I gotta make the drawing. The drawing of there you go. So we have this area. You can make it fancy. So one sample, I'm gonna create that here, so I know which one is the center. Okay, this is the center, so I will place the circle right there. So to create that, and then I'm gonna move it, and then I'm gonna use this blue dot. I'm gonna edit that, so I will rotate it, as you can see, and then I will place those indicators. I think it's too long. Okay, there you go. So I think it's too long. Let me make it smaller. I think that's fine right there. You see? And then we have this one here. This is really important. So what I'm gonna do, I'm just gonna generate one circle. So it will tell me that this is the first lead number one. So it's easy to do. So that's it. Put it right here. You're wondering why I place it here in the middle, so I can move it up. So it's going to be aligned with this one in particular. So I'm gonna place it here, and then I'm gonna move it up and make it smaller. I'm gonna make it smaller. Okay, I think I can move it down a little bit. That's fine right there. I think it's fine right there. There you go. So that is the lead number 1, pin number 1. So also you can make it even more fancy if you want to. This is what I do to make things a little bit more fancy. You can see this is a rounded, sort of like a rounded corner here. You can tell that they made the cat drawing. It's a little bit. Yeah, actually I can make that one too. It's not really necessary, but yeah, it's not really needed. It's not really needed to have it too much drawing on the PCB. So right now I'm gonna make those rounded corners. It's pretty simple. The only thing you gotta do is just, let me see, 1 millimeter should be just fine. 1 millimeter, just to make the corners look a little rounded. That's it. And then you're going to copy this one, place it over here. You can tell that it looks really nice. All right, one more. One more to go. By the way, always my recommendation of grid, always try to keep using the grid here. I use 0.25. That is one of the best grid to work with the Spring Layout 6. But you can go even smaller grid. You can go with also 0.025 millimeters. That will be on miles. I think it's mile. I think it's 0.98425. Oh wow. All right, so let's continue here. Creating the integrated circuit. It's ready to go. All right, so that looks really nice. So now we're gonna try to make sure that the silk screen and the okay, let's build the group. Let's see, I need to try to accommodate it in a way that it's going to look a lot symmetrical. Let me see, symmetry. The silk screen is just an illustration, so it does not need to be perfect, but to always try to align the silk screen the best you can, because remember we are working with 2.54 millimeter pitch distance right now. If we got here 2.54 millimeters by 10 millimeters, so that's the good thing right there. So it's ready to go. Okay, so let's check the legend here one more time. And it says here is a little complicated because it says the maximum is 10.92. I go with 10 millimeters, it's fine. And it says here the hole for the lead, you can tell here, it's telling me the hole, the thickness of this thin wire is maximum is 0.53. I got 0.60. I think it just should be just fine. As you can see, 0.60. It should be just fine right there to go. All right, so now the integrated circuit is complete. I can make one more drawing, but it's not really needed. But I can do it. I can do it right quick. One example. Let me create the fancy leads. It's not really needed, but you can actually do it. Okay, we got that. And then I'm going to duplicate this one here. Let me do a trick, guys. I like to be really artistic sometimes. Cheeky breaky. Okay, let's see. I like to be sometimes artistic. That's fine right there. And then you will copy this one here. You will, how many we have? Okay, we got 16. Actually, it's 8. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, we got 8. So I'm going to duplicate this one here, and then it's 8. There you go. So that's ready to go. It's not really needed. I just, fancy, just to go fancy there. So then I will copy this one here, rotate it, place it here, go down. You see? Oh my goodness. Okay, that looks really nice. That looks really nice. And then you will select the whole thing. You just drag the mouse. You will hold the left button. I think it is the left button. You will drag it, select everything, and build the group. So this one is ready to be saved. Ready to be saved onto your working area, your macros. Okay, let me see. Let me read the information of this Texas Instrument. This one is a IC phase lock loop NCP WR 16 deep. 16 deep. The package. I need to know the package. Package case. Device package is 16 deep. It just says 16 deep. 16 deep. All right. So this is the part number. Okay, one sample, guys. You have the integrated circuit already completed. The macro is done, ready to go. So in order to save it with all the information, let me see, where do I have? Okay, true holes, deal, we have deal. Okay, we got it here. So I'm gonna save it here. So I'm gonna save it here because these are our pre-made. These are pre-made macros for the integrated circuit. So I'm going to save that one here in particular. So what you're gonna do now is assign the information to this macro. The macro is plain by itself. It does not have any information. So what you gotta know, what you need to do now is to give it that macro the information, so you know what it is. After you drag it to your working area, you will double click to it and see the actual information. So I'm gonna create a component, and yes, so this is IC one sample, IC1 or IC2. So you will type that IC1 or IC2 depending on the situation. For now, I'm just gonna leave it default IC1 integrated circuit 1. So the value, I would say 16 deep, and then the part number, I will place it here. You can see there is more information on this thing. The package, you can use also the use pick and place data. You can, one sample, depending on the situation, you can have a 0, 90, 180 or 270, and here's the information of the package. So I will double check. It's 16 deep. Oh, sorry about that. No, I was saying that wrongly. The supply device package is a 16-PDIP. So that information, I'm going to place it here, paste it right there. So it's ready to go, and you can save it in many different ways. So it's ready to go. Then I'm going to press OK, and now this, you can tell this. You will see a little letter X here. That is ready to go, and then you will double click to it and look for the information. You can actually make the ID visible. You can make no, this information should be the part number. Yeah, this one here should be the part number. See this one? Yes. This one here should be part number. There you go. That's the part number. You can actually enable the component name, and you can tell this is ready to go. You can move it around you want to. You can select, you can put it here. You can put the information ID or anywhere you want. You can see, no matter where I want to try to place it, it's gonna follow. You see there's like a little white line. It's gonna follow. So you can place it here, whatever place you wanted to place that component. I can put it right here, or maybe I'll put it here meanwhile. So it's gonna look like that. So that one is complete and is ready to go. So now the next step is to save that macro, to save it. So I'm gonna select it. I'm gonna press this little floppy, and then I'm gonna give it the part number. I'm just gonna give it the part number from the manufacturer. So it's this one here. So this is ready to go. Paste. So we had the part number from the manufacturer, and save it. So now it's ready to go. And the only thing you got to do to use it again, you can just place it right here, and that's ready to go. You're not gonna see the identification, but you gotta keep double. Oh yeah, I forgot add as a component. I forgot to do that. Sorry about that, guys. Let's do it one more. Oh, I see. Okay. You see? Oh, add as a component. So that means if I enable this box, oh, you see? Even myself, I learned myself. You can tell it's ready to go. It has all the information, and it's ready. It's ready to go. Oh, so actually you can place it without the information. This is without the information, or with the information. That's cool. As a component, and then you place it here. Okay, one thing that I have not tried is the orientation of the component. I have not done that yet. the orientation of the component. Let's see one sample. I'm gonna do it. I'm going to save it, double click to it. Let's go with 90 degree. I just want to see if this make any difference. So I'm gonna save it one more time, the same part number, and then I'm gonna write here 90 degree just to see. Save. No, it's not doing anything. It's the same thing. Okay, let me see. Now, let me drag it to the working area. No, it's not doing anything. It's fine. It's not a big deal. Okay, I can delete this one here. All right, so it's ready to go. All right, guys, I'm gonna stop the video. I think you probably got the idea how to do it. You can make it as fancy as you want. You can make it really nicely, and I hope this video helped. You know, it's helpful for the ones that are using Sprint Layout 6. It's not really difficult. The only thing you gotta just pay attention, and you will do some drawings and stuff like that, just to make sure that you have everything correct. You can tell after I place the integrated circuit, this is the solder, the leads are white, and this is the surface mount. I mean, sorry about that, the SMD pads. So you will solder the integrated circuit right there. All right, guys, have a good day. I hope this video is helpful. All right.